Good morning, good afternoon, good evening, wherever you may be watching this from. This is Cornelius Lubinda with another video. So now we are going to look at the next segment of calculus, addition, and mathematics, alright, or pure mathematics. This is called the chain rule. So the chain rule is another way of finding the derivative, which is the dy dx, the rate of change, or it can help you find the gradient function. Okay? So if you remember from the previous videos, there was a video, okay, where we were finding the derivative of a function. A function given by y is equal to x minus 1 raised to the power 2. So if you don't know that simple way of expanding this particular bracket, this particular expression here, don't know how to expand it, it would be a lengthy process, because it means you would have to write it like this: x minus 1 multiplied by x minus 1, and then you start expanding those brackets. It's a lengthy process. Now, here, the chain rule is under a subtopic that we call, let me write it like this, composite, okay, this is a T, functions. Composite functions. Composite functions also means that the same as saying combined functions. So this is one function. Find the derivative of this is one function right here. Now we can make this one function be something we call a composite function, combined function. So which means this expression, okay? So there is x minus 1 in the brackets. That's what we call the core. It's called the core. So this core and then the function itself are two different functions and are composite functions. So we can call them two combined functions. What do I mean? So you can let what is in the brackets here, okay? You let this be equal to u. So you say u is equal to x minus 1, okay? So what is in the brackets? U is equal to x minus 1, and then the y is equal to whatever has remained. So since we have said this is u, y is equal to u squared. So the chain rule is dy dx is equal to dy du multiplied by du dx, in such a way that the du and the du cancel out. Mathematically, that is wrong. But a memory mnemonic, okay, a way of remembering this particular rule is you imagine it in your head that the du and the du there, they can cancel, sort of like you're simplifying, they can cancel out. But when you're answering a question, they never cancel out, because this is not a fraction. It is actually a derivative. dy du. So du cannot be cancelled with du because du is a derivative. So we're differentiating u. We cannot cancel that out. So this is a chain rule. Dy dx is equal to dy du multiplied by du dx. So you need to know this, and then you also need to know how to do this. What have I said? This, what is in the bracket, is called the core. So we let the u be equal to the whatever is in the core, which is x minus 1, and then y is equal to 2, and y is equal to u to the power 2. So we differentiate this, also differentiate this as two combined functions. So du dx would be equal to a 1, dy du would be equal to 2u. Then dy dx would be equal to dy du, you multiplied by du dx. dy dx would be equal to dy du. dy du there is your 2u there. You multiply by du dx. du dx right there is a 1, as you can see. Okay? So, one thing to note is that your dy du is a 1 right there, because we differentiated it in that way. Then to proceed, we can create more space. Okay? So it simply means we're saying our dy dx is equal to 2u. Now we cannot leave it like this, we substitute. So here we said let u be equal to x minus 1. So therefore dy dx is equal to 2x minus 1. 2 multiplied by x minus 1. Okay, but someone might not be, if you so this is in a, if you remember, this has been factorized, but in the previous video we found dy dx is equal to 2x minus 2. This and this are correct. This is where you factor out the 2, here you just leave it like that. But this one is more correct. Okay. So, summary of the video. We have learned the chain rule. dy dx is equal to dy du multiplied by du dx. And then we found the derivative using the chain rule, where we learned that what is in the bracket right there is called the core, and then we let u be equal to the core. So, u is equal to what was there, and then whatever remains, because we now know that all of this is u, so it will be u to the power 2. Then we just differentiate what we have formed. We formed this, we differentiate it, and then we go to 1. We differentiate this, we get a 2u, like that. Okay, so that's not the end of the video. There is something else. There is something else. Okay. So for this something else, I want you to follow me very carefully. Very carefully. Okay. You can have this particular function like that. So we are saying y is equal to the core raised to the power n. So what I'm going to write is going to be very confusing. So I want to follow. So we are going to say that our dy dx is equal to n, you multiply by the core, like that, and then n minus 1, okay, like that. So n you multiply by the core. We're differentiating the entire thing. What am I saying? N multiplied by what is in front here. What is in front here is 1, so it will be n. Then n minus 1 will just be like that, multiplied by the derivative. So d dx means derivative with respect to x of the core. This is a shortcut to the chain rule. So the chain rule is dy dx is equal to dy du multiplied by du dx. So you can choose to either use this or this. So derivative of the core, n multiplied by the core, n minus 1. So the derivative of the entire function multiplied by the derivative of the core. Okay. So you should know this, okay? Just know it. I don't know what you can do, just know it. Then your life will be made easy. But if it's confusing, let me explain it. Okay? So this is the core. I've already labeled it like that. So our dy dx will be equal to, our n in this case is a 2, you multiply by x minus 1, and then our n in this case there, n minus 1 again, to be 2 minus 1, multiplied by the derivative of the core. What is the derivative of x? So just differentiate what you can see. Here the derivative of x is 1. The derivative of negative 1 is just how it is. It's 0 because it is a constant. So we're going to have dy dx is equal to y dx is equal to 2x minus 1. That's it. And that's your final answer. So you remember when we were using the chain rule, we had to start saying let u be equal to that, that be equal to that, and then now we start differentiating both, and then we came to use the chain rule. If you want, you can just use this. This is straightforward. Just this. dy dx is equal to n core n to the power 1 minus 1 multiplied by the derivative of the core like this. This marks the end of this video segment. Thank you so much for following. Thank you so much for watching. This has been Cornelius Subinda with another video, and bye bye.